Okay, so we have been discussing about coal geology, and we were in the introductory part of coal geology. So this is where we ended in the last class. We talked about the percentage of recoverable coal reserves worldwide, and we said that India is not bad at all, which is around 7% of the total recoverable coal reserves of the world is in India. I think India is fifth or sixth of the largest coal producing countries of the world. And we also showed you where in India you mostly find the coal producing basins. So I will spend 2 or 3 slides to give you a little bit of background and history about the use of coal in the way coal was used by human being. So, history of coal production and use. A coal mined in the ancient cultures around 2000s, uh, 2600 years ago, okay, 2600 years ago. And that was mostly used to burn for heat. Okay. It was used for metal working all the way up to 300 before Christ. Okay. Mined extensively in the northern Europe by 100 AD and used in smelting iron and heating buildings. That is what in Europe around 100 AD people started to do with coal. In the Middle Ages, not much use of coal between 400 and 1200 AD. Resurgence in early 13th century, especially in Northern Europe and British Isles, used by metal workers and for heat. Use increased through 18th century, replaced wood, which was being depleted. So, why we are actually talking about the history is because one of the most important about the use of coal is related to the industrial revolution. So, coal is the sole thing, if you like, that essentially made industrial revolution possible. Okay? Simply because people learned to use. So what exactly is industrial revolution? In earlier days, before industrial revolution, all the works that were done by people were done by manual labor. In a sense that if you had to actually rotate a wheel or pull something up or push something, you had to use your own force or the force of the cattle. You did not exactly know the use of any mechanical forces, right? Which sounds very primitive, and it was primitive before people actually started to know the use of steam engines. You know, so what steam engines did essentially, the steam engines where the heat energy was converted to mechanical work, right? The heat energy was converted to mechanical work, and that heat energy was primarily coming from coal. So once people have learned to use coal for their own purposes, like to actually use them in steam engine, that essentially marked the dawn of industrial revolution. Okay, so what it essentially did, they powered steam generators, locomotives, yeah, and eventually electrical generators, made industrialization possible. So that is one of the primary role for coal. Okay. First, British Isles in 18th century, then continental Europe, and then US by 19th century. That is where, that is how the industrial revolution took place around the world. Okay. Coal in 20th century, production of anthracite declined following World War II. mines became depleted and flooded. Because mines became depleted and flooded, other fuels replaced coal for transportation and home heating. Because oil was starting to come slowly, production still strong in West Virginia, Wyoming, China, India, and Australia, used primarily for electrical generation. I mean, as I said, in those days and today it is true as well, most of the power station in India are still coal fired. Okay, you get electricity from burning coals. In the past 3 to 5 years, natural gas is replacing coal for electrical generation. Okay, so nowadays you also find a lot of gas power station which are essentially coming around the world, simply because if you burn coal, you actually emit carbon dioxide a lot. Of course, the greenhouse gas emission is substantially more than burning gas. And the second point is it doesn't only emit carbon dioxide; it emits other hazardous gases as well. Okay, so uh, slowly we have a tendency to go towards gas-fired power station from coal-fired power station, also in India. Okay. So now, how coals are mined? So before 1930s, most of the minings were underground. So we talked about it before. So mining can be of two types, especially coal mining. One is called open cast mining, and the second one is called underground mining, right? So what happens in open cast mine? If your overburden is not very thick, then you can remove the whole overburden from the top, and then you can virtually dig out benches and dig out coal from it. Okay, but if your overburden is of considerable thickness, then it doesn't make sense to actually remove the whole overburden. So what you do, you make some holes inside the ground, large holes through which shafts can go down, and through those shafts you go down and buy you make corridors, underground corridors in coal mine, and then that's how you take the coal out. Okay, and that is what we call as underground coal mine. Okay, so before 1930s, most of the minings were underground. Miners would often follow seam, extract with hand tools. Okay, this was not mechanical as well. Load in small rail cars by hand. So there are two types of underground mining methods. One we call as the room and pillar, and the other one we call as the long wall mining. Okay, let me just explain what are those two. This is my opportunity to talk some mining geology with you, but remember, you do get questions around the mining geology questions, although I will not be able to cover everything, but let me just try to explain what are the two basic types of underground minings are. Okay? Especially related to coal mine. So the first one is called room and pillar, and the second one is called long wall. Okay, so let's just see what room and pillar uh, mining is all about. Okay, so suppose uh, let me try to explain that by drawing few pictures. So suppose this is your top surface, and here is your coal seam that you want to mine. Let me draw it in a let me draw it with black color so that it represents coal. And then of course the next layer will be again, non-coaly layer, right? So this is the coaly layer that you want to mine. Okay. The first thing I said, this is what we call as this thickness is what we call the non-coaly top layer of the above the coal is called my overburden. Okay. So if the overburden is very thick, then I have to go for underground mining. If the overburden is not thick enough, then I can remove this whole thing, and then so I can if the overburden is not too thick, then I can eventually remove this this part, okay, and then start digging out coal. But of course, yeah, of course, if the overburden is thick enough, then I have to go for underground mining. Okay. Now let us say I am going for the underground mining and I am going for the room and pillar method. Okay. So let us look at what room and pillar method is. Let me just erase that first. We just okay. So this is the whole seam, right? And then so here was, of course, here is my top surface. Here is my top surface. Okay. And this part is not hollow, okay? There are non-coaly layers in between, but I'm not drawing them just to not make my sketch clumsy. Okay. So what I have done first, I have drilled a shaft. Okay. Right. So it's just simply like a vertical corridor through which people can actually come down. Okay, with the help of an elevator. So now the miners are standing on the on the coal top surface. Okay, so now they drill further. They actually take the shaft further. So this is perhaps my top surface of the coal seam, and then they dig further out, and so like a hole, and they are standing here. They are standing at the bottom surface. Yeah. Now they will try to dig out the stuff. Okay. So the first they can do, so they will go in this direction, this direction, this direction, and this direction. All these directions, they will start to dig the coal out. Okay. So the first thing they do is to, you know, mine it like this. Okay. So what do I mean by that? That they mine, just draw first. So they mine everything within the dotted area, yeah, but they don't mine, these square shaped areas. So they are left as, so if I draw it in 3 dimension, they are left as columns, right? They are left as columns or pillars. So columns and pillars of coal are left. Okay? So and the rest of the area, this corridor which I have marked by dots, are actually mined. Okay, so this is what we call as room and pillar method. So why these pillars are left? These pillars are left simply because they want to have stability. If you remove those pillars, what will happen? Everything will break down. This whole ground surface will kind of subside, you know, and there will be terrible accidents in under the coal mine. People will die and stuff. So everything will break down. So everything, all the overburden, whatever is left at the top, is kind of supported by these pillars. Okay, by these pillars. Now, if you are a private miner and if you are too greedy, what would you do? You'd like to leave minimum number of pillars and maximum number of coal you want to take out, right? So if you do that, what would happen? Invariably, you will commit an accident. And that has happened in India plenty of times. I mean, I don't know if you know about Chashnala. If you don't know, you can search Chashnala coal mine accident and you can read all about it, how many people died there. And so you have to actually mine, because this is a really, really risky business. You have to really mine them very scientifically, do a proper stability analysis so that you leave enough of these pillars intact in the ground and you take the rest of the coal out, right? And then once the coal is taken out, they are again, uh, you know, they are again pushed back up using trolley. And then, of course, you have ground transportation here, railways and everything that takes the coal out. So this is how it happens. Okay, so this is room wall mining. And the second one is called, sorry, room and pillar mining. And second one is called uh, long wall mining uh, in your underground mine stuff. Let me just show you what happens in long wall mining. So in long wall mining, rather than leaving such so this is my coal seam. Rather than leaving such pillars, what they do, they essentially, you know, so this part is left intact. This part is left intact, like few walls are left intact, and then the dotted part is actually mined out. Okay? This is what we call as long wall mining. Long wall mining is actually more safer than your room and pillar mining, but then of course it's also more expensive, simply because you don't take out as much as coal as you want, because you have to leave these walls actually intact. Okay? So this is what we call as long wall mining. So there are two types of mining, we said: open cast mining and underground mining. Within underground mining, we do see long wall mining and room and pillar mining. Okay, I hope the mining method is clear to you. Let me ask if anyone has any question around these mining methods. Was it clear, or anyone has any question? Aniket, was it clear for you?
Yes, sir. It was
Okay.
clear.
So before 1930s, most of the minings were underground. Miners would often follow seam extract with hand tools, load small rail cars by hand. Room and pillar mining was common. Raw coal transported to surface, processed and crushed in breakers. Waste coal, the calm gob, dumped into huge piles. Okay. So coal mining and production. Coal is mined by two methods: surface or open cast mining, underground or deep mining. Underground mining currently accounts for about 60% of total coal production in the world. In several important coal producing countries, surface mining is more common because it's more safe, right? Because you don't get inside the deep mine and try to take the coal out. Actually, as a geology student, I mean, we had the opportunity to visit mines. I mean, our final year masters um, were dedicated. One field trip for almost 25 days were dedicated to mine and industry visit. Okay, it's very difficult to explain these things on a in a classroom, and there are plenty of intricacies in mining methods. The whole mining geology itself is a full course. So it's always better. Maybe in future, some days we will also be able to take our students to mines and show them how mining is done. Because mines from Bhopal are also not far. You have plenty of open cast and underground mines also in Madhya Pradesh. So it's a good idea whenever you talk to your give feedback to the department. It's a good idea to insist them on having such field courses where you are exposed to mines, because uh, nowadays also one of the still in India, I mean 60 to 70% of the geologists are actually um, gets job in different sorts of mines and mine related jobs, right? So it's not an area to be kind of overlooked. So it's important that you get an exposure of the mining geology, but unfortunately we don't have the opportunity as yet. Hopefully it will come soon. Anyway, so underground mining is currently account. Okay, we talked about it. For example, surface mining accounts for around 80% production in Australia, while in the USA it is for about 67%. In India, though, the open cast mines for coals actually is not that big. It might be around 30 to 40%, but rest of it is around 60% is underground mining in India. The choice of mining method is largely determined by the geology of the coal deposit, which includes the thickness of the overburden, of course. So you can see here some beautiful pictures of open cast mines. Okay, so this is at the top of a mountain, and this is in a valley. You can see beautiful benches, and from where the coals are extracted, you can see this large, gigantic vehicle which carries coal. In this particular time, it's actually carrying overburden because it is brown. So these are called dumpers. Okay. So emergence of new technologies, large steam shovels, drag lines, permit surface mining, remove of overburden to exposed coal, often results in large pits, mountain top mining, as you can see here. Okay, so the another important thing as a miner, if you own a mine, now so coal mines used to be private in India. Some of the coal mines were private in India. Then it was completely nationalized. Okay, so when I was a master student, some of the coal mines were still private. It was then completely governmentalized, and then again, the private coal mines are coming up. Uh, from last year. Okay, so but now the coal blocks will be bid to um, multinational companies. Okay, so India Coal India Limited is still one of the most profit making companies of India. Yeah, it's one of the Navratan companies of India. So it's a good place to work as well. And I think I sent one advertisement for you guys. I don't know if you have looked at it or not. I asked the office to send it to you, or I sent it in WhatsApp. I don't exactly remember. This time, Coal India is actually recruiting, okay, in big numbers. So, and I think they recruit from Gate. Okay, so it's a good opportunity for you guys to uh, get a good score at Gate, and if you are interested, to go for Coal India Limited, because that's a good job to have, and you will be able to practice geology a lot if you are not interested in research, of course. Okay, so worldwide consumption of coal. So you can see how it's actually increasing, and this is the projected 2030, and the consumption of coal is not going to decrease soon. For India as well, you can see the consumption is keep on increasing. So to 2020, we are somewhere here. So the benefits of coal, it's a high energy density material. So if you burn a lump of coal, you get a lot of energy. It's an abundant fuel. So most of the coal is still to be dug out of the ground around the world. So there is still a lot of coal left, relatively inexpensive. We know that the coal is not that expensive. Employs many thousands of workers. Okay, often found where the energy is needed. Say, what do I mean by that? Say, for example, India is a country where we really need energy. We have to support so much of population, and it's I mean, the gift of nature that India has such a big reserve of coal. So it's good, only good. It's the gift of the nature that India's demand can be supported by uh, so much abundance of coal. It is reliable. Why it is reliable? For example, uh, you don't know unless you actually drill a well, whether which actually costs again around $20 million, whether you will be able to get oil or gas out of the ground or not. But on the other hand, you know the predictability of coal seams is easier. They are there. They are more reliable. You have the energy there. Easy to transport as well because they are not flammable. I mean, not easily flammable. You cannot. I mean, it's but whenever you carry oil or gas in a large tanker, there is always chances for accident. But coal do not generally catch fire like that, so it's easy to transport. Drawbacks: terrestrial impacts, habitat destruction. So these are coal wastes. You can see it is almost making another mountain at the site. Okay, so it's one of the causes for deforestation around Jharkhand and Chhattisgarh are these coal mines. Okay, and the associated problems that to the political associated problems that happened. I don't want to say more around bad management of the mining blocks, because it actually distracted habitats, right? Both for wild animals and for human being. Okay, so there is a large terrestrial impact, aquatic impact because abundant mine drainage. So coal waste mine disposals are often fairly toxic. You know, so there is a whole amount of research that goes around how to make the coal mine drainage least contaminant, contaminant free. Okay. So that sort of research is going on. I think Ashish also does some research around that front. Atmospheric impact, of course, there are particulates, that forms aerosols. If you burn it, it can create sulfur dioxide, and if you burn it, of course, creates greenhouse gases. So there is a very, very large environmental impact, both if you want to mine coal as well as if you want to consume coal. So it has its pros and cons both ways. So how it is converted to electricity, you know about it. I'm just take you through quickly about this diagram. It's in Shing's book. It is actually fairly well described. So there is coal supply, which is through a conveyor comes to a pulverizer where it is crushed, and then it goes to a boiler. In that boiler, of course, a lot of heat is generated where it is burned, and then, of course, that heat essentially creates steam. That steam rotates a turbine, and electricity is generated. Okay. So you know about this, but just to remind you what happens. So coal and electricity, 68% of India's coal power 68% of power stations of India are coal fired. Okay. So we are heavily dependent on coal and coal India. So you can imagine if we stop making coal from tomorrow, 70% of the electricity is gone. Okay. So we will cease to exist. That important it is. Coal and steel, of course, most of the iron ore mines of India are also in the Jharkhand and Bihar and that belt, Odisha, that belt. And most of the coal mines are there as well. So that's why these big companies like ISCO, TISCO, they formed in that, they actually colonized in that area, right? So they get the raw material in terms of iron ore. They also get the raw material in terms of coking coal. They mixed both of them together, and that creates and is burned in the furnace. This is the blast furnace. They're burned in the furnace, as you can see. Coke, iron ore, and some other limestone, of course, is mixed together, and then from that slurry, essentially steel comes up, right? So coking coal is also absolutely important for the steel industry, and coal is also used used heavily in the cement industry. Okay, so if you look for India, so around 106 billion tons of proven reserves. Yeah, so indicated around 123 billion tons, inferred around 23 billion tons, total 267 billion tons of total coal reserves, 250 years at present level of consumption. So that means if we just depend on coal, okay, and we consume at the level like we are doing, we can sustain. We will not be devoid of any energy for next 250 years. Okay, and they are largely concentrated in Western India. These are the main coal bearing areas. So you can see here this Jharkhand, West Bengal, Odisha, Chhattisgarh, a little bit on Andhra Pradesh, Maharashtra, MP, okay? And then of course Assam, Meghalaya. Yeah, these are all bituminous coal. Okay, and then there are lignite deposits also in Kutch, some in Rajasthan, some in Jammu and Kashmir, okay, and some in Tamil Nadu. So this large deposit, of course, come from the Gondwana basin, and of course there are some from the Assam basin as well. Okay, but this is not all. The Assam coals are not as good as the Gondwana basin coals. So this is where the heart of the India's energies, at least in terms of electricity, comes from, right? And yeah, that's all I wanted to say on the introductory part of coal geology. We will uh, talk more about coal from next class onwards. So if you have any question. We'll get into details of coal in the coming classes. So the first question that I have, have you got the book? Singh and I forgot the name. Singh and what was it? Chandra and Singh. Have you got the book? Have you asked the library?
Yes, sir.
So what they have to say? Have they sent it to you?
No, sir. अभी सेंड नहीं किया उन्होंने.
They have not sent it to you. Can you just CC me in that email so that they hurry actually, right? Otherwise they will keep forever. Let just CC me in that email where you have requested for that book. Okay.
Okay, sir.
Any other questions you might have?
No, sir.
Anyone else? Okay. If not, then I will stop it here, and I will see you tomorrow during the talk at 5. Thank you.